All right, let's jump right in. We're living in this incredible age of technology, right? But it brings up a huge question. How do you effectively teach a subject as complex and hands-on as modern robotics? It's a challenge that might just force us to completely rethink how we learn.
I mean, really think about that for a second. How do you actually teach a machine to see the world, understand what you're saying, and then physically do something? We're not just talking about lines of code here. This is about perception, logic, and real-world interaction. It's an immense challenge, but the answer might be hiding in a totally new kind of textbook. So here's how we're going to break this all down. First, we'll dig into why this is so challenging. Then we'll introduce this brilliant new framework, a blueprint, really, for teaching this stuff. We'll look at its core tools, see it in action with a real lesson, and then zoom out to see what this all means for the future of learning.
Okay, first up, let's get a real handle on the problem. Teaching modern robotics, what the experts call physical AI, goes way, way beyond what you can get from a standard textbook. You've got this whole world of cutting-edge concepts that are all tangled together.
Just look at all the different pieces a student has to understand. We're talking about the huge idea of physical AI itself, but also things like humanoid robotics, AI agents, even specific software like ROS2, that's the robot operating system, and complex ideas like digital twins. It's a whole ecosystem, and trying to teach these things in isolation just doesn't work. You never see how it all connects. So, how in the world do you tackle that kind of complexity? Well, that brings us to the solution. A brand new framework, actually born out of a hackathon, that serves as a blueprint for teaching these topics in a way that actually works. It's officially called the Physical AI Textbook Framework. And the keywords here are practical and engaging. It's designed to make sense even if you're a total beginner. Think of it less like a dusty old textbook and more like a hands-on practical playbook for building robots. And here's the philosophy that makes it tick. Right from the get-go, it's aimed at beginners. The core goal is to ditch the dense theory and instead teach through practical, real-world examples. It leans heavily on visuals and simulations to make abstract ideas feel concrete. And everything is explained in simple, clear language. It's all about building intuition, not just memorizing facts. So that all sounds great in theory, but how does it actually work in practice? Let's break this blueprint down into 4 really simple, actionable steps. And what's cool is you could use this for teaching almost any complex topic. Here they are. It looks simple, right? But this little loop is incredibly powerful. You start by clearly explaining what the topic is. Then, you immediately ground it with a real-world example so people get it. Then, and this is the magic part, you get the student to actually do something with an interactive exercise. And finally, you wrap it all up by telling them what the main point was and why it matters. It's a complete learning cycle in 4 steps. All right? Theory is one thing, but let's see how this blueprint actually performs on the road. We're going to walk through a quick sample lesson to see how these 4 steps come together to create a learning experience that really sticks. Okay, so our example topic is Vision Language Action Systems. I know, it sounds super technical, but stick with me. It's basically the tech that lets a robot see something, understand a command about it, and then, do something. So following our blueprint, step 1 is the clear intro. We just define the system as something that connects seeing, understanding, and doing. Simple. For step 2, we give a real-world example. Imagine a robot sees a bottle on the table. You say, hey, pick up that bottle, and it actually picks it up. Just like that, this complicated idea becomes totally real and understandable. Now for the fun part, step 3, where we make it interactive. We'd pose a thought experiment to the student. Okay, now it's your turn. What are all the tiny little steps you'd have to program for a robot to do something as simple as pouring a glass of water? This forces them to think like an engineer. And finally, step 4, the big takeaway. These systems are absolutely essential if we ever want robots to be truly useful in our homes and workplaces. And this all leads us to the big picture, because this blueprint isn't just a great way to teach robotics. It's really pointing to a huge shift in how we should approach education for any complex, hands-on subject in our crazy, fast-moving world. When you boil it down, we're moving away from this traditional model of just passively reading a book, focusing on theory first, and memorizing a bunch of facts. This new framework is all about active doing, putting the real-world application first and focusing on genuine understanding. It's a massive shift from just learning about something to actually learning how to do it. There's this quote from the source material that just hits the nail on the head. The goal is to teach through practical examples and visuals, not just dry theory. That really says it all, doesn't it?
It's about making learning come alive. So I want to leave you with this one last question to chew on. As we're building these incredibly smart ways to teach artificial intelligence, it kind of forces us to look in the mirror. If this hands-on, interactive, application-first model is the best way to teach a machine, what does that tell us about the best way for us humans to learn? Not just about robots, but about everything?